Speaking about use cases, the first one and the most major one is data centers. And as you may know, like a typical data center is a quite dynamic environment where workloads tend to migrate from computer source, from one computer source to another in terms of different hardware placement and so on. And the most of the storage in data centers is backed by an object store, and like it works pretty well when there is not much performance needed in such case. And speaking about NVMe over fabrics, this is a kind of technology that has some issues integrating into data center environment, specifically due to the absence of an ability to map the fast storage to the particular consumer. So example situation is where you have a set of compute nodes, just like regular plates, and there are not enough free or like spare PCIe slots for sticking in NVMe cards, and there are still some consumers, like applications or virtual machines, that need this fast storage to be there. When they migrate to another compute node, they assume that this storage should be present at the target node as well. So what we are doing with our NVMe over fabrics target initiator is basically solving this issue. So we are able to teleport the storage from point to point where it's required. The second use case is SMB. However, not really like SMB in our terms, but it's mostly how VMware, Microsoft classifies them, but still.
Yeah, so that's with less than 10,000 employees.
Yeah. So there are still two products, and mainly SourceSpace Direct and VMware Virtual SAN. And there are some issues related to expanding such clusters. Mostly this is due to the licensing cost, and if you need to scale computer resource or storage resource separately, the official way to do this is basically to add one more node, two more nodes, and so on. So in order to avoid extra expenses in terms of scaling high-performance storage, we also can get use of our technology to basically provide the way to scale it without the necessary, without the extra expenses that are usually necessary when you add another node.
You can actually today support VMware vSAN with NVMe targets. I mean,
as soon as we get the initiator, we'll be able to support this scenario.
Yeah, so this is just like our plans.
Oh, okay.
And the customer for that is like any brownfield deployment which already utilizes VMware vSAN or Microsoft Storage Spaces Direct.
But the Microsoft Initiator is already available? Is that?
Microsoft Initiator is going to be available within the, I think like mid-October. And then VMware, the plan is to have it ready by December.
So yes, this mostly solves the same issues with data centers, but like translated to the smaller environments. Still, the need to teleport the fast memory. And the last use case, and this is basically we are going to use this technology in our own appliances. So currently we use ICER as a backbone protocol synchronizing the storage from node to node. And as we move to the faster storage, and as we will offer also the NVMe-based appliances, will need something more efficient, and this is the technology that will help us to solve this issue. So thank you for the attention. I think we're full with kind of the Q&A session. So
yeah, I think the question is now to you. Where do you see this technology?
So I mean, one of the problems with NVMe over Fabric today is high availability, and multi-pathing kinds of capability don't seem to exist. I mean, how does your solution address some of those problems?
So right now we're in the first phase where we want to deliver lossless NVMe to the initiators. And
lossless would be high
lossless would be
availability.
like use as little cores as possible, as little latency as possible, and deliver raw performance over fabrics. And with NVMe, I really think that like the initiators right now have all the software-defined tools to combine the NVMe and fulfill the requirements for mirroring them, erasure coding, and doing stuff like that. Right now, if we do it on the target side, we can sacrifice compute on the target side for doing this. And we ran several tests where we combined the NVMEs and then delivered them as a single logical unit to the initiator. But right now, we have to polish that technology before we can offer it to the public. That's why we envision 3 use cases for right now. And as soon as we have the technology polished, we will add use cases, and it will become just software-defined storage, which is NVMe-centric.
And you guys are selling software only, or you sell
software
hardware?
or appliances.
Hardware appliance.
Or appliance, okay.
Yeah. It's also available in Azure, but I don't think it's something you can do with NVMe in Azure yet.
Right, and the customer buys,
Yes.
the customer buys the
Like
NV
non-verbal reactions.
the customer buys the Optane SSDs themselves, or it's part of the appliance purchase?
If they purchase the appliance, then we will supply the NVMe SSD.
And if they go for software only, they can use their own NVMe cards.
Yeah.
Right.
We don't enforce use of particular NVMEs. The only thing we would recommend is just work with the Mellanox networking, because this is the one we always use. We have tested it. We know for sure it works. And if we're doing software-defined storage close to light speeds, we need proper equipment to make sure it's 100% reliable.
But speaking of improper equipment, have you started working on NVMe over TCP as opposed to Rocky yet?
So I think it's possible to implement it. Or the thing why we went for Rocky, otherwise, back in the day when we started developing it, there was no DPDK. So that kind of was a natural decision back in the day to just go Rocky and don't start building something for Windows, because we ended up not building anything for Windows and just doing the proven functionality inside the Linux virtual machine, just because it works better, it's more stable,